Greetings everyone, let us now try to solve this third example. So we need to prove that for all positive integers n, the summation of 1/2 plus 1 over 4 plus 1 over 8 up until 1 over 2 raised to n is equal to 2 raised to n minus 1 over 2 raised to n for any n. Okay, so like in the previous examples, the first thing that we need to do is to show that P1 is true. So P1, so 1/2 n is equal to 1, right? 1/2 is equal to 2 raised to 1 minus 1 all over 2 raised to 1. Now this will be 1 all over 2. So therefore, P1 is indeed true. Okay, so now that we've done that, let us now proceed to the second condition. Again, we write pk. So 1/2 plus 1 over 4 plus 1 over 8 plus dot plus 1 over 2 raised to k is equal to 2 raised to k minus 1 all over 2 raised to k. And also, we write our pk plus 1 so that we know what we're aiming for in the next steps. 1 over 4 plus 1 over 8 dot plus 1 over 2 raised to k plus 1 is equal to 2 raised to k plus 1 minus 1 all over 2 raised to k plus 1. Okay, now the next step is to assume that pk is correct. Is true. So if pk is true and that through algebraic operations we can come up with pk plus 1 from pk, then we can conclude that pk plus 1 is also true. If we've done that, if we've shown that, then we have proven the statement that we need to prove. Okay, so let's copy this pk first. It's like what we always do. Okay. Here we have our pk. Now, again, our ultimate goal is to obtain pk plus 1, right? So our kth term is this one. So the k plus 1 term, in order to get that, we need to add 1 over 2 raised to k plus 1, right? So 1 over 2 plus 1 over 4 plus 1 over 8 plus dot plus 1 over 2 raised to k plus 1 over 2 raised to k plus 1 is equal to 2 raised to k minus 1 all over 2 raised to k plus 1 over 2 raised to k plus 1. Okay, now our task is to modify or to simplify this right hand side to see if we can actually come up with this result that we got here for pk plus 1, this one right here, right? So what do we do? First is we need to evaluate its denominator, right? We need to add these two terms, but our denominators are different. So what can we multiply to 2 raised to k in order to get 2 raised to k plus 1? So what do we need to multiply to 2 raised to k in order to get 2 raised to k plus 1? So from the law of exponents, you have to multiply 2, right? So this is 2 raised to 1. So this is also equivalent to 2k plus 1. So that's from the law of exponents. So we should not forget that. So in order to get the same rational expression right here, we will do this one. 2 raised to k minus 1 all over 2 raised to k. And now we will multiply that by 2 over 2. So this is the same thing, right? Plus 1 over 2. Oh, I'm sorry. And then plus 1 over 2 raised to k plus 1. So if we evaluate that, you will get 2 raised to k plus 1 minus 2 all over 2 raised to k plus 1. plus 1 over 2 raised to k plus 1. Okay, now that we have the same denominators, we can then add 2 raised to k plus 1 minus 2 plus 1 all over 2 raised to k plus 1. And then what? So we can simplify this right here. So 2 raised to k plus 1 minus 1 all over 2 raised to k plus 1. Let's take a look. So it is indeed pk plus 1. So again, from pk, we've assumed that this is true, right? That is our first assumption. Then we simply added 1 over 2k plus 1 to both sides. So we added to both sides, meaning the equation is still true. So after doing that, we arrived at pk plus 1. Therefore, we can conclude that pk plus 1 is also true. So having done that, we've proven this statement right here. That this is true for all positive integers and from 1 to positive infinity. And that is actually really powerful and cool. Okay, thank you for watching this video, and I hope you learned something, and we'll see you in the next videos.